Hello students, so myself Shubham Kumar Rai, your maths educator. So today in this lecture we will be looking after the derivation of Heron's formula. As you all know about Heron's formula, that the formula says under root s minus a, s minus b and s minus c. But how the formula has been derived, that we will be looking in this chapter. For that you must be aware of the formula, that is area of triangle. So what's the area of triangle? So basically we know that the area of triangle is half into base into corresponding height. So let me write that. So as we all are aware of area of triangle, so the formula says that half into base into ch. So what does the ch means? So it is basically the corresponding height. So let me write that, it will be more easy and feasible for you all. So basically ch means corresponding height. So this is the basic formula of area of triangle, right? But as we all are aware of this and we need to derive the formula, so we will be using a triangle. So let us assume that we are having a triangle that is PQR, right? So these are the vertex of a triangle, and let us assume that the name of the triangle is PQR. If there are three sides, so let us say that the sides of the triangle are, let's suppose the first side is A, the second side is B, and the third side is C, right? So these are the sides of the triangle, that is A, B and C. Now if I just take the perpendicular over here, or you can just have this height, so it will be like this. And if I say the point which is bisected over here, so it will be M. Okay? And now we need to just have the name of this. So the name of this will be H. This is height, so assume as H. Okay? But the thing is that when we solve or we are having the form, we are not aware of this. So let us assume that this is X. Because it has been bisected, there are two sides now. So it will be X. The limited will be what? Left out will be B minus X. Because the total was B. And if I just have the sides like this bisected over here, it is X. So left out will be what? It will be B minus X. I hope it is clear till here, right? So now after that we will be using a form of equation, or you can say the formula, that is Pythagoras theorem. I know you are all aware of that. So let's write that first. So in this we will be using Pythagoras theorem. Pythagoras theorem. So what the Pythagoras says? So as we all are aware of, the formula is hypotenuse square is equals to perpendicular square plus base square. If I just write this formula in detail, so it will be like hypotenuse square equals to perpendicular square, right, and plus it is base square. As we can see that we are having a triangle PQR, and if I just take the height is, it is divided into two triangles. Let's suppose this is our first triangle and this is our second triangle. Okay. Now we will be applying the Pythagoras theorem in our first triangle. So if we apply that, so it will be what? It will be hypotenuse square is equals to perpendicular square plus base square, right? So if I see in our first triangle, what is the hypotenuse? It is PQ, right? So we will write it here like PQ square. If I talk about what is the perpendicular, so perpendicular is what? PM. So here we can write like PM square. And what is the base? Base is QM. So here we can write like QM square. Now we will be just substituting the value over there. So what is the value of PQ we have taken? Or the sides of, or the hypotenuse of the triangle. So basically it is A square, right? And what is the PM? That is H. We can see. So it will be H square. And what is QM? It is X, right? So now I will be just shifting the form. It will be like a square minus s square equals to h square. I will be using this form to get a very efficient equation so that it will be helping us a lot. And let us assume that this is our equation number first. So we have got an equation, that is equation number 1, from our first triangle that we have used by using Pythagoras theorem. Now the same we will be following for the second one, right? So let's do the same process for the second one. Okay, so now we will be applying the Pythagoras theorem same in our second triangle. So let's write the formula. Basically the formula is, as we know, hypotenuse square is equals to perpendicular square plus base square. So what is the hypotenuse over there? It is PR. So we can write here PR square, right? What is the perpendicular over here? It is PM square. And what is the base? You can see here, that is MR square, right? If I just substitute the values over there, what is the value of PR? We are having the side as C, so let's suppose here it is C. And what is PM? It is basically H. And what is MR? It is basically B minus X. Try to be very attentive over here because we have total side as B and the left out will be what? B minus X, right? So I can write it like that. C square is equals to H square plus, as we are aware of algebraic formula, right? We have learned in our class 8, that is A minus B whole square. Since we can write like A square plus B square minus 2AB, right? This is the formula. So we can just write or the split with the form, that is B square plus X square minus 2BX, right? Or I can just switch the formula over here and write it as C square is equals to H square plus B square plus X square minus 2BX. Or if I just switch the formula, right, in the same form like in this H square, so it will be what? It will be C square minus B minus X whole square we can take is equals to H square. Like this also we can write, or as I have converted over there, you can just use that form also. So it will be like this, right? Now we have got our second equation. Let us suppose this is our second equation. Now here we can see that this is also H square and this is also H square. We have got the two equations from our triangle that we are having. Now what we can do? We can just equate both the equations, right? So now let's write in the next slide and let's equate them and see what we are getting. So let us assume that we are having the first formula as H square is equals to A square minus X square. This was our first equation, as we all know, right? And the second equation we had was H square equals to C square minus B minus X whole square was our second equation. Now what we will do? We will be just solving this now on equating equation number 2, and first we get what we will be getting. So here if we equate the form, we will be having like this, that is A square minus X square equals to C square minus B minus X whole square, right? If I just split this in the format, so we will be getting A square minus X square equals to C square minus, it will be like B square plus X square minus 2BX, as we have discussed this formula in earlier slides, right? Okay, now we will be just changing this and opening the bracket, so sign will be changed. So it will be A square minus X square C square minus B square minus X square plus 2BX. As we know that the same side having the same sign and the same form will be cancelled. So this will be cancelled and this will be cancelled. So now we will be writing the left out terms over here. So it will be what? It will be A square. We will just shift this. It will be plus B square. Shifting will be done. So it will be minus C square equals to 2BX. Right? if I write this in the form of x, so it will be a square plus b square minus c square, and we will just transpose this, it will be 2b equals to x. I hope it is clear till here, right? So let's have this as equation number 3rd. So let's suppose this is our equation number 3rd we have got. We have got the value of x over here, right? What we will be doing now? So we will be just assuming that this is the value of x and we can just put the value of x in our first equation. So we will be getting our hypotenuse. Okay. So what we will be doing? We will be just putting the values or substituting the values over here, and we will be just forming the format. So let's suppose the equation we are having, it is h square equals to a square minus x square. So let's write here. Now substituting the value of x in equation number 1st, we get, what we will do, we will just substituting the value over here and we will be checking the value of x over that. So as we all have the formula, that is h square is equals to a square minus, what is the formation of x? It is like this. We will just substitute here. It will be a square plus b square minus c square upon, it is 2b whole square, because it is x square and we have the formula as x. So we will just substitute the value of x over here and just square the whole form, right? If I just square them, what we will be getting? So if I write like this, it will be h square is equals to a square minus a square plus b square minus c square small bracket whole square. If I just square this, it will be 4b square bracket, right? Okay. If I just switch again, it will be a square. If I see here, it is 1. So I can just take the LCM over there. So it will be what? It will be 4b square, and it will be like 4a square b square minus bracket a square plus b square minus c square whole square, like this, right? I hope you have understood till here. Now what we will do, we can see that if I can write 2a whole square, it is what? It is 4a square b square. So we can see the formation over here, right? So we can just say that it as h square is equals to 2ab whole square minus a square plus b square minus c whole square whole divided by 4b square. So now another algebraic formula we can look after over here, that is, since a square minus b square is equals to what? It is a plus b and a minus b. So we can see here it is a square minus b square format. So we can just figure it out with the formula. So we will be getting the answer as h square is equals to 2ab plus a square plus b square minus c square. The first form, that is a plus b, and the second we will be getting 2ab minus a square minus b square plus c square. As we open the bracket, the sign will be changed upon 4b square. I hope it is clear till over here. And now we can see the formation over here, that is a plus b whole square. What is that? It is a square plus b square plus 2ab. So we can see the formation over here, right? So this form a plus b whole square, and if I see in this, it will be like that, a minus b whole square. If I just simplify and write this form, that is h square is equals to a plus b whole square minus c square, right? And here we can write c square minus a minus b whole square. So it will be like this. I hope it is clear till now how we have just simplified this formation, right? Now let's move further. Again we can see that a square minus b square and a square minus b square. Now let's write over there and just simplify more form. So we will be getting as as we have our last equation, that is h square is equals to a plus b whole square minus c square, and other we have c square minus a minus b whole square, right? And it was whole divided by 4b square, right? Okay, if I need just simplify this again in algebraic form, we can write as h square is equals to a plus b plus c, a plus b minus c. The first formation is completed over here. And again, if I write c plus a minus b and c minus minus a plus b like this, and whole divided by 4b square. I hope it is clear till here, right? Now, as we all know that p represents what? Perimeter, right? We all know that p represents perimeter. And what's the perimeter of triangle? It is sum of all sides. It will be like this, or we can say the boundary, total boundary, right? So as we know that the formula for perimeter is a plus b plus c. But in this we have learned about semi-perimeter, that is represented by s, right? So s means what? Semi-perimeter, half of that perimeter. So how it will be written? So it will be written like that, that is s is equals to sum of all sides and divided by 2. So we can write in the form, in this formation, that is 2s equals to a plus b plus c. So now here we have got our new formation, this, and this, let's suppose this is our equation number 4. Okay, so we have got, that is a plus b plus c is equals to what? The value we have got as 2s. Now if I say here, it is coming in the format, it will be 2s. But what about this? So here we can see that a plus b minus c, what we can write? So here we can write as a plus b plus c like this, right? And we can write as 2c. Okay, so what it can be written as? It will be written as 2s minus 2c. Here we can have 2 as a common, so we have got s minus c. So these are the formats that we will be using over here to get our answers, right? So these are the format that we will be using here. Okay? Okay, after that we will be using here. So let's move further and understand in detail about this. Let's have a fragmentation over here. Yeah. Okay, now if I just move further, okay, and write is in the form, that is h square is equals to a plus b plus c is written as 2s into, it can be written as 2s minus 2a, other can be written as 2s minus 2b, and it can be written as 2s minus 2c whole divided by 4b square, right? If I move further, it will be h square equals to 2s. Here we can just take out the 2 as a common, it will be s minus a, 2 as a common, s minus b, 2 as a common, s minus c whole divided by 4b square. I hope it is clear now. We have taken 2 as common from all the formation, right? Now here we can see that it is 4, so the 2 will be cancelled over here. What is being left? So here we can see that it is left with h square is equals to s minus a, s minus b, s minus c. The 2 we have picked and written as 4 over here, and the left will be b square. As we all know that whenever the square shifts over, we are having what? It is written as under root, right? It can be written as under root. So if I just shift that, so I will be forming, that is h equals to under root 4s, s minus a, s minus b, s minus c whole divided by b square. Okay, now I can write like 4 will be coming out, as we know that it is the square of 2, so we can write as 2, b square will be written as upon b because the square, and the left out the term will be like s minus a, s minus b, s minus c. Now let's form an formation and mark it as very important format, because this is a very important format, and let us assume that as equation number 5. Now we have got final formation like this. But is it similar with Heron's formula? No, it is not similar. So what we will be doing? We will just equate in the form of area of triangle. How? So let's see. As we all know that area of triangle is what? So we know the formula, that is half into base into corresponding height, as we have taken this earlier, right? So if I just substitute the value over here, what we will be getting? So area of triangle, I can write like this also, right? Half into base, we can write as a b. What was the ch or the corresponding height we have got in our equation number 5? So we can see height we have given as 2 upon b under root this. So we will just substitute the value over here from equation number 5. So we will be getting what? 2 upon b under root s minus a, s minus b, s minus c. And now here we can see that b is b cancelled, 2 is 2 cancelled. What was the left out item we have? Left out term we have, that is area of triangle, that is equals to under root s bracket s minus a, s minus b, s minus c. So as we can see that now this is looking similar like what? Heron's formula. So finally we have hence proved it, how the Heron's formula has been arrived. So we have come to a result, that is area of triangle, that is according to Heron's is what? Under root s, s minus a, s minus b and s minus c. I hope this solution was very clear, right? So in this next lecture we will be looking after the problems or the sums on base of this Heron's formula. Till then, let's revise this and come in the next class with proper formation of the derivation, and after that we will be solving the sums over this. Thank you everyone.